All right. Well, since we started the meeting recording, we will probably have a few more people signing in as we go. Um, Today is our transformative vertical flight working group meeting on focus on public services, but also commercial application and everything else. And this is meeting 102. Today is Thursday, December 18th, 2025. We have a wonderful guest speaker, uh, John Veilleux. He's the chairman and CEO from Rotor Corporation. And as usual, before we get into that, I'm going to shift to a quick meeting announcement. Just I know many people already know this very well and already plan to attend, but I think since this is one of the what I consider very important gathering regarding the transformative vertical flight topic. And the forthcoming meeting in 2026 is going to take place in San Jose, California in the US, and the meeting is scheduled for January 27th to 29th. So anyone who has not quite complete your planning, please do so. I'm looking forward to meet you guys over there. And with that, I'm going to move back to our introduction of our speaker. Again, John is going to talk about today the title is Land Rotor Personal Air Mobility Reimagined. And he's going to cover a broad topic. You can see on the meeting announcement here. But I would like to briefly introduce John. He provides strategic leadership for Land Rotor Corporation, setting long-term vision and overseeing major corporate initiatives, board governance, growth, ownership, and the technical integrity of advanced air mobility program. Uh, Interesting background. He has a broad, interesting background. I'll only cover a little bit here that he's a certified private pilot, fixed wing, single engine land with helicopter and multi-rotor training. And he brings more than a decade of commercial drone experience as an early adopter under FAA Part 333 and a former FAA safety team representative for unmanned system. So with a strong background like that, I mean, it's a very interesting to see what he's working on now. You can see the picture that John has a lot more to share. So with that, I'm not going to hold up the meeting. I'm going to try to unshare if I can find my way. As I say, Zoom and I doesn't always work together that nicely. So I'm still looking for my unshare button on the screen. Okay, I think I know where it is. Yeah, it's always hiding it from me on top of the bar. Hey, Shannon, were you able to stop my sharing from your part? Ah, there you go. I can see my share button now. So actually, I am unshared. Stop sharing here. Okay. All right, John, you should be able to share yours now. Sorry about that, but
Okay.
here's our
Oh, that's
speaker.
okay. That's okay. So I'm smiling, Johnny, because I'm the same way. I'm always a little bit slow with things. Um, but thank you so much. I am thrilled to share and to be with this group here today. Land Rotor is still fairly new on the scene. Um, what a lot of people don't know is we've been doing this for more than a decade, even though we first incorporated the company about 5 years ago. We've actually been working on the technologies for some time. And first of all, I want to make sure everyone can hear me okay. Things good.
Yes, loud and clear.
Okay, very good.
Gotcha.
So, so Land Rotor is really got an interesting approach to market. Our philosophy has always been how do we mass produce personal air mobility, and how do we really get to a future of flying cars, and can it be done? And so that's always been rudimentary, and the reason I share that with you is because it's foundational for us today, and our trajectory, and what we put together. So I thought it would be great if I can get my screen to share. I'm going to share with you some pictures that go back 13 years ago to when we got started. That's right, that's 2012. And you all know that's really before drones became a thing. And it's also interesting, we actually started in San Jose, California. So people see that we're in Orlando, but it all began in San Jose. So I'm going to try to share my screen now, if that will work. Can you all see that?
Yes,
All
looks
right.
good.
So the other thing I have to do is I need to find my the thing I'm looking for is right over here on the right. And how do I move that? I'm not sure. Bear with me. I've got a folder right behind that window. That's all right. I'll get there this way. There we go. We're going to get there this way. So I have just a few photos to share with you, and you might find it interesting because it's our heritage. So there you have it. This is in a garage in San Jose, and that's my business partner, Ansel. So this is what we don't often share with anybody, but this is how it all started with us. A combustion engine. That's right. And here you see some of the early attempts uh, at ducted fans using a combustion engine. Now, again, this is 13 years ago. And here we have two combustion engines because we realize it takes so much power to turn rotor blades enough to, for manned flight. So I wanted you to see what's going on here to get some, again, these are all very, very early developmental tests. So if you can imagine this machine at 500 pounds, and then we're going to put a man on it and try to fly it. So here again, as the technology, what we were doing continued to evolve, you'll notice the belts and the pulleys and all of that stuff in place, trying to achieve manned flight as a quadcopter. So this was a quadcopter. Now, at that time, we weren't seeing any other examples of people trying to use this configuration as a quadcopter for personal flight. But that's how we were doing it 13 years ago. So 3 years later, in 2015, everything changed because consumer markets began to get popular with drones, and hobbyist parts became available. So you see, we went all electric. So these are electric motors now, no more combustion engine. So that was a huge game changer. And without 500 pounds of engine, a combustion engine, a battery stack. So the technology suddenly made manned flight possible. And so began the other test of different configurations with that technology. This is just all drone technology coming together. This is around 2016. There again, here we have 16 motors, just more motors, more batteries to appreciate the power that could be achieved with drone technology at that time. And it finally led to this, an actual working personal air vehicle. I should find these shocks rather interesting. and but it actually flew. So there you have it. But still, very interesting. And that led to about 2017 with this vehicle, still a very dangerous looking contraption. So that's when Ansel personally went to rethought the whole thing and came up with the idea of a carbon fiber body to have the vehicle look more appealing for consumer markets. Because this is a scary looking thing, even for me now. It doesn't look like anything most people would want to get into. So that led to the development of this vehicle, which is all based on those same principles. What we have here is two electrical systems with 8 motors, independently operated electrical systems for redundancy, with a carbon fiber body, with batteries. It comes in at 249 pounds. So it fits nicely with FAA regulations for Part 103. There again, just a few pictures of what that vehicle is and what it looks like. So this is now 2019, and that vehicle is ready for market. And then COVID came, and that set us back. And during that time, through COVID and getting ready to reach the market, we still were faced with a lot of challenges in that vehicle. Certifications, certification, regulations, safety, so much, cost. Most people can't afford one of them. And what do you do with it? At the time, it was about a 20-minute flight time at a $70,000 MSRP. That's actually doubled now with the way the costs have gone up in the last 5 years. But the reason I'm sharing this with you is because that vehicle design, which you've now seen the history behind it, and that's what's brought us to today with our new designs that are really tailored toward having an attractive product for consumers. And the big challenge with where we are today, it's still out of a price range that most people can't afford. And we come back to that question, how do we close that gap? I'm going to close this window now and see if I can get out of, make sure I don't close out of the, am I still there? There we are, stop here. There we are. So if anyone has any questions along the way too, I want to encourage you to please go ahead and interject, step in, and I'm happy to answer any questions. But what I just showed you there is the history behind our technology. Now, I also want to point out one thing we don't have is our vehicles really aren't that advanced. When you look at the development of tilt rotors and hybrid wings and all of these things, Land Rotor has remained somewhat simplistic in a basic quadcopter configuration. And if you've ever seen these in action, it's not a smooth ride. Unlike the major players that have really developed advanced flight control systems and unique airfoils to gain efficiency, we don't have any of that. In fact, for an industry that's called advanced air mobility, Land Rotor is really one of the least advanced products out there. But we've remained foundational about how do we mass produce this technology for consumers. If it's plausible that the future will be filled with people using personal aircraft like automobiles, if there's really going to be flying cars in our future, how do we achieve that? To make it so it's safe and affordable to the average person. So that's why we've remained to that core of the simplest in design and foremost safety. And I like to draw from that example. We look at the automobile industry, those early cars that came off the assembly line 120 years ago. Um, they were not high performance cars. They were very, very simple and basic in concept. And the point was to for consumer adoption, affordability, and a practical use case scenario. Um, but they were also dangerous at the time. I was just reading the other day about the people that would get seriously injured just from those hand cranks. And it wasn't until years later when the invention of the electric starter came that made those vehicles a lot safer. So, in terms of real consumer adoption, how do we take this technology and present it in a way that it becomes viable and safe and all of that? Or are we just dreaming about it, you know? So, for that reason, in order, our focus is safety, first of all. And the more moving parts we have, there's a chance that something could break. So, we're trying to keep it as simple and as safe as possible, hence the Model A and the Model T. So we have fixed rotor blades. We don't have anything fancy going on, although the designs look really cool, and we have phenomenal feedback from consumers that love them, and they say, "Hey, I want that," but it's still so far away to really make it practical. Even with upwards of an hour flight time now, it's um it's at a price point in terms of safety and regulations. We've got a long ways to go as an industry. So we have, in the last few years, we've shifted our focus from rushing to get our product to market to focusing on filling that gap that exists between average household income and this advanced air mobility, these technologies. Now, what's really wonderful is all of the innovation that's happening in the infrastructure and the changes in policy. And it's such a fascinating time to be living in. We look at the major players in air mobility and air taxi services, and it's wonderful. Uh, I'm 59, and I can't think of a time where I've seen so much coming together so quickly. Even despite all of the challenges, it's moving forward anyway. A few years ago, a close friend said to me, he said, "John, you don't have a chance in the world of succeeding with that. It's going to go nowhere." And and my colleagues and I we're going to do it anyway. And and that's what's wonderful. Even despite the challenges we've seen in this industry and some of the early players showing great promise, some have already given up and moved on. But there's still such a global push, and it seems that we're breaking through some major barriers in consumer adoption of air mobility and how it fits in society. So I'm thrilled about that. And that's not Land Rotor's market. We're not competing with anybody. But I'm sharing all this stuff with you and our heritage because we recognize the fact that in order for us to get to a future where people are living the dream, how do we get there? So our focus has really been more in line with. I like to use that example with Apple Computer. I mean, there was a time when Apple Computer shifted from being an a computer company to more about building an ecosystem with products and services that really enhance people's lives. The introduction of the iPod was revolutionary because it introduced a wearable product that people could carry with them. And then, of course, Apple Tunes and all of the products and services that emerged from that time. Land Rotor is very similar in that way, and we're we're working to discover ways on how we can bring advanced air mobility into the hands of consumers so everyone can enjoy it. So what we're really doing is building an ecosystem, a consumer adoption engine for advanced air mobility without being a competitor to anybody. We're really, our business model is focused on connecting with consumers in such a way that I don't see anyone else doing right now. So it's something we're trying to, it's just our approach. And so we talk about personal air mobility reimagined. That's uh, that's the story behind that. Any questions so far?
Yeah, you mentioned that the ride may not be as smooth as you desired. Is that tied to the size of the rotor, the motor control, response time, and so on? Are you on your way to have a better riding, uh, more comfy air mobility device?
Yes, we are, and I want to expand on that. You see, for a fixed rotor blade configuration, like a basic quadcopter, you we all see the like a model drone, and as it moves forward through the air, it's going to have to be in this position, um, to move through the air, unlike the major air taxis that are being rolled out. The advancement of those tilt rotors make it so that the passengers can still sit in a comfortable level configuration. So what we have would be most appealing to a person in the sports recreational vehicle market. Um, People that buy jet skis and snowmobiles, they want that thrill, that ride. They want to experience the sport of it. And that's really what we have right now in this current configuration. So it's not a practical vehicle that is ever going to be a flying car, but I I think that we can play a pivotal role in bringing consumers to the technology and giving them that experience of operating one, and that's what we've developed with the robotic system as a tethered system, so that it's a safe environment where people can experience it.
Interesting.
Yeah.
Yeah. What's the picture behind you?
Oh, yeah. This is a it's a KUKA robotic arm. So the biggest thing that's probably happened to us toward this space is partnership with KUKA Robotics. KUKA is known the world around for manufacturing robotics, but they have the only passenger approved robotic arm, which is widely used in theme parks around the world and cruise ships. Um, so it's a 3,000 pound robotic arm um, that's already in use. It's an off the shelf product. So it makes it very nice because we set out with the vision of designing, building our own tethered system, which would have taken even more years for us to do. So a partnership with them is great because they already have the equipment. So we're just taking something that's already widely used and curating it with flying car experience. But by doing so, we also realize that we can collect a lot of data by putting actual aircraft on the robotic arm. We can test things in the laboratory and with people on them to use that data to help refine the technology of these vehicles.
Are you
Good question.
familiar with the ducted fans that Hiller used for their personnel uh, hover hover vehicles?
No, no, tell me.
Well, I notice you don't roll your edges, your leading edges on your ducts at all. And Hiller would get be. Yeah, now I don't have the data in front of me, but Hiller would get something like 30 or 40% of its lift of its vehicle just from by rolling the leading edges of their ducts correctly, because the accelerated air coming over the lip of that duct would create lift on the duct lip, and
Mm-hmm.
and they greatly increase their efficiency that way. And now, of course, I'm not sure. You know, you have to be careful if you try to go anywhere very quickly in horizontal flight. Of course, that duct lip gets, I would think, get real critical real quickly because of possible separation, flow separation on it. But anyway, that's so they greatly increase the efficiency of their ducted props by doing that.
Mm. That's fantastic, and it makes sense to me too. We've learned
Where
that
are you?
we're based in Orlando, Florida. Yeah,
Okay, because there's a Hiller Museum in Bay Area, and
fantastic.
so if you're out in San Francisco, it's uh, what's the name of that airport? It's a GA airport in
Van Nuys?
no, that Van Nuys is
That's,
Los
that's
Angeles
Oh,
area.
San
oh
Mateo, I
yeah.
believe. San Mateo or San Carlos Airport,
San no,
right down the street from us.
wait a minute, San Carlos? Maybe it is San Carlos. Anyway, it's it's uh, it's where Larry Ellison bases his TBM aircraft. But anyway,
Ah,
it's a
is
GA airport.
it is San Carlos. Yep.
Okay, it's a GA airport in Silicon Valley, San Carlos, I guess. And there's a Hiller Museum there. You know, the old Hiller aircraft.
mhm.
And anyway, do you, if you want, do you want to put your email contact information? Oh, there we go. Someone put there it is. Hiller.org.
Okay.
You see it you
Eh,
see it in the chat?
Yes, yes,
Fire
I
up the
do. Yeah.
chat. Okay.
Ah, there it is. Yeah, yeah. Good. Now this is great. I'm afraid I'll lose all this if when I close out. So I'm gonna
Are
copy
you
that and just paste
yeah.
it.
Are
Good.
you gonna give your contact information or
Yes, absolutely. I'm gonna message that right here. There we are. John at landrotor.com. Let's see, John at landrotor. I think I got that right. Yeah, that's great. Did that come through?
yeah.
Okay, well, this is great information. I appreciate it. Um, we have learned that this technology is not efficient. It's not really efficient use of energy in terms of moving a person or any cargo through the air. And that's why I've been really intrigued to see the innovations that have come along with those hybrid airfoils and tilt rotors. It's really fascinating. Um, but what we have is a basic quadcopter at a Model T, if you will, a Model T capacity, entry level consumer product. It definitely is not a fuel efficient means of moving about. So the idea of introducing some innovation and changes, with that ducted fan, um, it could be really, really valuable for us.
Also,
Um,
I would look into the Bell X-22.
Alex 22. I'm gonna write that down.
It's it's a tilt duct aircraft. And then let's see, what was it, VZ4 or VZ5 was the Curtiss tilt duct.
Oh, a Curtis tilt. Okay, good. Well, we're learning new things all the time, for sure, and it's just wonderful to see all of the innovations happening. And every time I turn around, there's something new that um, somebody is mastering.
Yeah, it's a
Uh,
VC4 doke.
a doke.
Doke, D-O-A-K.
Oh, okay. DOAK.
And it
VC4.
says the whole Wikipedia page on it.
Ah, okay.
Yeah, there's
Yeah, I'll go there. Check it out. I appreciate that.
John,
Yeah.
you're right that, quad rotor really is not the most efficient, energy efficient flight vehicle. If you want to maximum horizontal hovering lifting, helicopter do a lot better job. Still do. And you want to go horizontally fast, fixed wing airplane does a better job. But
Mhm.
on the other hand, I still believe, some of the configuration and design, the maximum efficiency may not be necessary because if you look at personal watercraft, Sea-Doo, jet
Mhm.
ski, whatever, and you say, okay, probably I put a number out there. Only 10% are used for the lifeguard rescuing, other utility purposes. High percentage of it is recreational, and people are burning gasolines for fun.
Yeah.
Yeah, it can go places. People do, jump on those, go places, and the larger platform they go fishing or whatever. So I still hold the belief, thinking about what you're doing right now, a fast efficiency is not always necessary for broad acceptance.
Mhm.
If enough people can find use for it, a different way of using it or a different way of playing with it,
Mhm.
that can be a sizable market.
Yes. I agree with you, Johnny. And that's the market we're thinking about for this type of product is really the sports recreational vehicle market. Um, we've had some discussions about partnering with existing um, recreational power sports markets and retailers uh, to bring a product of this nature to consumers. Um, eh, in talking about the technology, there's one grave concern that we all still have, and that is regarding to the safety. When I'm glad you brought up helicopters and the comparison with fixed wing, because both of those platforms offer a means of landing on the ground in the event of a catastrophic power failure. I think you know where I'm going with this. Obviously, a fixed wing airplane, the idea is you can still glide to the ground in a power failure. Helicopters, they've got the tilt rotor blades, they can auto rotate, and the idea is you can still glide to the ground. And this technology doesn't offer any of that. And so it's a big question that we all have. Um,
Up,
there are, go ahead.
I would say up to about a 4 or 6 passenger aircraft.
Hmm.
What might be the optimal solution are those deployable parachutes.
Yeah.
Like Cirrus.
Yeah,
Cirrus has a 4-seater that has that. And
absolutely.
and I
Yeah.
don't I don't know how large an aircraft you can go and still use that type of system, but
Mhm.
but Cirrus is certainly using it on a 4-passenger system.
Absolutely.
So I'm
And that's
sure I'm sure a 1-passenger. Now the trouble is, well, let me think about that for a second because you're going to be always very low to the ground.
Yeah.
And
Yeah.
there is a time. Maybe I should take my comment back because there is a certain time, deployment time and space that those systems need.
Right. No, you're right. I'm glad you brought it up because the parachute is something that we actually we have on the drawing board. I mean, there's companies that manufacture those, so they're readily available. It does add about $14,000 in cost to our vehicle, um, but a parachute system is one. It's one solution, but like you say, if you're 60 feet above the ground, perhaps it's not going to do you much good. So,
Well, yeah, people are working on the zero parachute, so they basically not counting on the vehicle dropping to open up the chute. They basically, shoot out a rocket, with the chute. So
yes,
that reduced
yeah.
the height requirement, but I'm not sure
Hmm.
you can do actual, if you're 10 feet above the ground, I'm not sure that, But on the other hand, I noticed you have counter-rotating prop in each duct.
Yeah.
And one of the possibility we have thought of is that slightly oversize the motors, and the flight computer will decide, whenever the vehicle, and then like all drones does that, when you detect the imbalance, if you lose a motor or something, lose the power core, lose the control, uh, as long as it's not throwing the blade, you may be able to have sufficient lift out of the remaining rotor in each of the duct, so you can have one failure in one of the duct and the other still operating properly, but one duct has to work the remaining motor over harder to balance out the lift losing by one of the two rotor and the blades. So I mean, you don't need to be maximum performance at that time. You just need to be enough to save landing. And
Yes.
flight computer should be able to manage that kind of response in time to rescue whatever. So anyway, just sometimes a little bit oversized motor and maybe a little oversized blade uh, might provide you the certain aspect of the extra safety that you're looking for.
Yes. No, you're right, Johnny. And our test has showed great promise with that. Um, we only need one of those electrical systems to for our operation. So the fact that we have two systems in place, so we could shut one completely off and the other one is just fine. So in the event of a bird strike or if something were to happen, um, so the redundancy factor definitely is it's the biggest thing we have going in terms of safety. The other thing that we implemented and is showing great promise is the use of a LiDAR system. Currently, we're just using it for vertical distance ranging off the ground, and it showed great promise because when we have the LiDAR switched on and the parameter set at 4 feet above the surface right now, so it just keeps the vehicle from going any higher than 4 feet off the surface. And it makes an interesting use case scenario. And our plan behind that was could there be a market for this technology where we're actually keeping people out of controlled airspace? If you can imagine, you look at the FAA regulations for hovercraft, for example. Uh, it's a whole different set of rules for hovercraft in terms of operating in controlled airspace. But we never challenged it. We didn't pursue it. But I just want to tell you that LiDAR technology has come such a way that it may help us to create safety barriers for consumers. And the picture I showed you a while ago with our newest version of that quadcopter uh, along a test track, um, that's with a LiDAR system. But there again, I'm not sure where we're going with that. People like it. It's cool. Is it just a sports toy? Um, somebody invented jet skis and snowmobiles, and the plan was never to have that become part of mass transit, for people to use it for, you know, to get to where they're going, like motorcycles and scooters. There are those recreational toys that have a place, boats and all of those things. So it could be that that's the market for that product.
That's an interesting thought. Uh, you may want to keep your eye on the discussion between FAA and Coast Guard.
Hmm.
The debate came about hovercraft are always being treated as a marine vessel, so FAA
Hmm.
pretty much just stay out of it.
Yeah.
Actually, you only fly a few inches anyway. But
Hmm.
the argument came from the wind and ground effect machine.
Yeah,
There's several development
exactly.
on that, and
Yeah.
the for the most of the part of the world, the wind and ground effect machine, if it stays seeing ground effect most of the time, only capable
Hmm.
of short hops, is
Yeah.
typically governed by the marine organization, like our Coast Guard and so on. But in the US, there's a argument ongoing right now. So if I'm correct, and I think the Congress give A and Coast Guard a limited time to work it out. Who has
Hmm.
jurisdiction in what phase? So
Hmm.
hopefully that will come to a conclusion that big may, enable you to explore that space.
Yeah.
that would be lovely. I would love to see that.
I agree with you. I was surprised to see a hovercraft with the wings, and they have an altimeter on it. The one I was looking at, it has an altimeter in it. So, but it's still a hovercraft. I'm like, huh, why is there an altimeter in it? But it made me smile.
If you're only going to be 4 feet off the ground,
Mhm.
then what you might look at is kind of a combination landing gear and emergency uh, bubble or bag underneath,
Mhm.
so
Mhm.
that it could be like a two-stage bag in that
Mhm.
it could serve as a landing gear, soften the landing, um, and it could be two-stage or multiple stage in that there you could pop, like if you came down real hard, it would like
Mhm.
pop the outer bag to absorb the impact and still have maybe some give in an inner bag. And you could do
Mhm.
that in stages. You could do it at 2, 3, where it would the harder you come down, the outer bags pop first, and then
Mhm.
finally leaving a tough inner bag for the final absorption of the
Mhm.
impact.
Mhm. Absolutely. I love it. There is another component about being close to the surface that no one's talking about in in the industry that I ever hear, but it keeps coming up in our meetings at Land Rotor, and that is the ability to use wireless transfer of electricity. And that would change a lot for us in providing use case scenarios for air mobility. If you take batteries out of the equation, and we're going back to the Tesla coil, philosophy, what Nikola Tesla was demonstrating a long time ago. Well, not that long ago, but uh, the ability to get the power to that vehicle without batteries being, the primary. Um,
Well, there's a lot of loss in that type of system.
yes, that is true.
You lose
It really.
and if you start amping up the power uh,
Mhm.
in certain frequencies, you could you have to be careful that you don't get into a frequency that you start
Absolutely.
microwaving the pilot.
Yeah,
and
I agree with you.
literally
Yeah,
cooking them.
yeah, I agree with you. Did any of you see the road with a demonstration with the Tesla? Was on I forgot where it was. I only saw it recently with they have a charging system in the road, charging lane. I I assume it's real, but I didn't read any more about it. But I thought, wow, that's a charging lane.
Yeah, the
Pretty.
induction charging has been in good, well under development, and in some cases actually already in commercial use. But to transmit a longer distance, if you want to be fly everywhere and be able to aiming the transmission toward the air vehicle, that may take a little further development. So,
Absolutely.
actually, John, we have a lot of experts here on this meeting that you may want to see who else may have some input or questions.
Yeah, I'd like to open up the floor to anybody. Uh, we're definitely out there in Land Rotor as a company, and our motivation is how do we get this to mass adoption? What can we do that really makes a product that is viable and safe and accessible for mass adoption? So yeah,
Oh, well, sorry, I'm speaking again. A quick question.
so
The weight of the vehicle, is it within the ultralight category or is heavier than the ultralight category?
yeah. It meets with Part 103 experimental, just under 250 pounds with the battery, and that just barely squeaked in. So the black carbon fiber one that you saw, if we do anything with it, put leather seating on it or something, would be overweight. So I mean,
And
we could.
one possible early adapter, before we get into very mass market,
Mhm,
putting our working group focus on the possibility if it's within ultralight and in other words, you don't absolutely require a license to operate. You still need to go through a lot of training. Don't take me wrong. Might make a potential use for first responder in short range deployment. I'm not quite seeing that there's several companies working on this concept. It might actually be kind of part of the crowd, the small crowd, that
mhm,
everybody's exploring what's the practical way to enable a first responder to respond quickly, especially if you are in Los Angeles. Well, forget about the big city. I mean, traffic is going
mhm.
to slow down the ground ambulance,
Yeah.
but even if it's in the medium smaller cities, we can still get delayed. Or if you have a river, you have to go across the river. The bridge is 10 miles away, and you actually
Mhm,
just try to cross the bridge, to the somebody saying medical needs and something. Uh, it's still a lot of challenges, obstacle to overcome. But if you're able to carry one person, that may be a direction can be explored.
mhm.
I put, as a working group, team members, I think we absolutely love to see something like that come true. Yeah.
Hmm. Me too. Yeah, that's a great point. Um, I, yeah, I've seen a few people that are working toward that sector and bringing emerging technology for life-saving systems. So it's great to see. I mean, there's so much going on in this industry. Um, certain jets, the Jetson One, they're demonstrating a lot now with racing them, and uh, this stuff is finding its place in the world, and Land Rotor is just a teeny tiny small part of that, and focused on the consumers though. And going back to that robotic arm system, as a lot of people don't know, but Land Rotor Corporation is really a holdings company. Land Rotor actually consists of three companies. We have two LLCs, Land Rotor ATV, which is our manufacturing side and the aircraft itself. But then we have Fly Drive LLC, which is purely focused on indoor venues and bringing in the robotic systems with the aircraft to develop a type of indoor skydiving, if you will, instead of indoor skydiving, indoor sky driving. I bring it up because our business model is very similar to indoor skydiving, in that it's the franchising arm of our company. We're still yet to prove ourselves and show that we can be profitable and bring something of great value for consumers and all of that. But that's the vision we're going and connecting with consumers with a business model and scaling the company with immersive entertainment in an environment that gives everyone a chance to experience one of these vehicles. As you can imagine, anytime we go out in public and we have one of the vehicles on display, it always draws a crowd. And people just want to come and sit in it and take pictures. So the newness of this is still there, and it's very exciting for people when they get to just sit in one. And so that's part of our venues that we're developing, is to really bring the technology closer to consumers and give them an experience and help educate them. And it ties into my last point that I had on that bullet point list, is where Land Rotor fits with the OEMs. And what we see is not as a competitor for any of the players, but really developing a social infrastructure, a liaison, if you will, of bringing consumers to the industry, helping them to learn about these technologies. And we're actively seeking to work with major partners in not promoting Land Rotor's brand, but promoting other brands that are leading the industry, with the idea, as people get more and more comfortable with the technology and come to understand it and see those major brands out there, we believe they'll be more likely to want to utilize those services as they become available. So that's our position, and what we're trying to achieve. It really is just help everyone else out.
John, I had a question for you. We work on something similar. It's a personal flying machine, Hexarotor. I was curious though, have you guys taken outside investment?
Yeah, I'm glad you asked. We haven't. We've been 100% privately funded, just through angel investors. We are at a point, we've been talking about it more and more. In order for us to grow, we're at a point we need to consider putting together a Series A, because we're on that edge now.
Okay.
Of where are we going with this, and so that's our business model that we have now. And now you understand our corporate structure in terms of Land Rotor Corporation being the S Corp, currently registered as an S Corp. But it's coming up more and more. Do we want to go public? We're going to raise, a Series A. Where are we going with this? But I'd love to talk with somebody that knows about doing that. It's definitely not my area of expertise.
Yeah, it seems like a lot of those companies, the air taxi companies, are going with these SPACs, the whole special purpose acquisition formula for fast tracking going public, that kind of thing. The second question I had for you though is, I didn't see in your pictures, are you actively flying with people and things like that?
No, not at all. So the black carbon fiber model that you've seen, we have over 200 flight hours on that. And we stopped doing demonstrations with that when COVID came along. And we haven't flown it since. We've been, back at the drawing board, like, well, where are we going with this? What is our plan? And so our plan is really shifted toward consumer adoption. We know we have the vehicles and we can build them, but how do we really connect with consumer markets in a way that leads to mass adoption of the technology? So, if you ask
Well,
me, go ahead.
oh, I was just gonna say, I love it. I think it's a great looking design and all that. I didn't mean to take over the conversation there, but
Oh, no, I
it's
love it
funny
as
how
well.
we're all asking the same questions, and there's so many of us, pushing for the same kind of objective. And I think that it's great when we can come together on calls like this and compare
I
notes.
do too. I agree with you. About 6, 7, 8 years ago, our validation that reassured us we were onto something was seeing other companies emerge with their idea for products. And in that time, some companies, they went through a round of funding, they built an amazing product, and then they just went away. But companies kept emerging, and so it's always provided us with a level of confidence that, you remember what I said earlier in this meeting, where a friend of mine said, we have no shot at going anywhere with this. And we said, we're going to do it anyway. We just have a push. We're going to do it anyway. So it is important to share notes and support each other in this community. I'm not interested in competing. I just want to know, how can we, how can we make this, really happen?
One thing I would do is I would look at Google's Kitty Hawk.
Yep.
Uh,
Yeah, I know Sebastian years ago. He was so kind to me. Sebastian Thrun, who head up the company, and of course Larry Page funded it. So about 4 years ago, I reached out to them and I presented the idea of an indoor tethered system. So that was before our partnership with KUKA Robotics, and it was just too much out there. But Sebastian Thrun was very kind. He responded in email, and he said that's not anything that they're interested in entertaining. And it wasn't even a year later after that they announced that they give up, and the announcement said that we have determined there's no viable market for this. And I thought, there has to be. I said, this is like IBM all over again 50 years ago. I'm sure you guys know IBM was the big computer name in town back in the mid 70s. And what's interesting is IBM determined, they had done a market study and determined there's no market for a home device. And it's so interesting because just a couple of years later, a very
There will
young
always be
Steve.
recreational interest. You just got to get
Yeah,
the price and reliability.
absolutely.
Actually,
Um,
John, we have not only today's participant already has a lot of expertise here. Among the transformative vertical working groups, there's 300 plus experts in all different aspects: technology, flight testing, structure, design, supply chain, investment, and all that, legal regulation certification. So one of the things you might want to, you're invited to stay engaged in the working group. It can probably draw some valuable uh, partnership, leverage, whatever. And I think we all have the similar drive and desire to see what you're pursuing happen. I'll just introduce you right here. It's Al Lawless. Uh, on the, say, the flight test, the development, training, whatever, you want to say hello to Al. I mean, he's
yeah.
one of our expert of the experts. So make sure you get in touch with Al on that.
Yeah, I just shot you an email with the link so you can reply and I can tie you
Okay.
in with the council.
Fantastic. Thank you. It's been great being here and meeting you guys. I really thank you for your time. It seems we're all in this together, and no one has all the answers, but collectively, I believe it's going somewhere.
Yeah, I think
Um,
we all believe that. Otherwise, we won't be here. So,
yeah.
I think we're at the time of the end of the meeting. And John, thank you very much. This is a very
Thank
interesting
you.
topic and what
Thank
you're
you.
doing. And for everybody, have a happy holiday. And
Yep.
I'll see you guys in January.
All
All right.
Thank you. Bye-bye.
Thank
Thanks,
you.
Johnny. Thank you,
Bye-bye.
John. We got a lot of Johns today, everywhere.
Thank you, Johnny. Thank
Thank
you.
you.
We meet next year.
Absolutely. See you guys around.
Yes,
Merry
bye.
Christmas, Johnny, and